Okay, let's unpack this. A skull on Mars. Seriously, that headline it grabs you by the antenna, doesn't it?
It really does. You
Yeah.
see something like that announced April 11th, this picture from Perseverance.
Yeah, this dark, kind of jagged rock. They're calling it Skull Hill.
And immediately your brain just goes there, right? Trying to find that familiar shape in this, well, alien landscape.
Totally. It's that pareidolia thing kicking in. Our brains are hardwired for it, even millions of miles away.
Uh-huh. And it's fascinating how that pattern recognition works. But as cool as a Martian skull sounds, our deep dive today isn't really about that.
Right, we're not confirming little green men here.
Not quite. We're digging into the actual science, looking at the reports, NASA's own analysis, trying to figure out what this rock really is.
And maybe how it got there, sitting in Jezero Crater.
Exactly. Think of this as your shortcut to getting the real story behind this, let's say, peculiar find.
Yeah, okay, good. So Jezero Crater, let's set the scene. Why is Perseverance even there?
Well, Jezero is super interesting to scientists because all the signs point to it having been a big lake billions of years ago. We're talking water, sediments.
Prime real estate for potential ancient life, maybe.
That's the hope. And Perseverance is currently exploring the crater rim, specifically near a spot called Witch Hazel Hill.
Witch Hazel Hill, got it.
And it's near this geological boundary they've named Port Anson.
Port Anson, what's special about that?
That's where you get this meeting of light-toned rocks and darker rock outcrops. It's like a geological crossroads.
And that's where Skull Hill popped up.
Right, in that interesting transition zone, yes.
Okay, and the reports classify Skull Hill as a float rock. That sounds slightly odd.
It does, doesn't it?
Yeah.
But it's a standard geological term. It just means the rock didn't form in that exact spot.
So it wasn't born there, it arrived.
Precisely. It was transported somehow, likely by forces from Mars' ancient past.
Back when Mars was maybe warmer, wetter?
That's the idea. Think ancient rivers, maybe lake currents, moving rocks around, then erosion over billions of years.
Wow. So this rock could have had quite the journey. That adds a whole layer of mystery.
It certainly does. Understanding how these float rocks moved tells us a lot about those past Martian environments and the forces at play. Water, wind, they sculpt and transport things over vast timescales.
So let's zoom in on Skull Hill itself. What does it actually look like based on the images?
The pictures are from the Mastcam Z camera, which is incredibly sharp.
Right.
And it shows this rock that, well, it really stands out. It's much darker than the ground around it.
Which is more light-colored and dusty, you said?
Exactly. Very light-toned, dusty terrain. Skull Hill, in contrast, is dark and it has this sort of angular surface. Not smooth.
Jagged, almost.
Yeah, jagged is a good word.
Yeah.
And crucially, it has several small pits dotted across its surface.
Pits. Okay. And what about the immediate surroundings? Anything interesting there?
Actually, yes. The surrounding soil, the regolith, seems to contain these tiny little spheres.
Spheral.
Spherals,
Yeah.
like the blueberries opportunity
Sure.
found. Similar concept, yeah. Their presence here suggests, a complex geological history just in this little patch of Jezero.
Fascinating. Okay, back to the pits on Skull Hill itself. Any ideas how they formed?
There are a couple of main hypotheses floating around.
Okay.
One idea is that Skull Hill might be a conglomerate, like made of smaller bits of rock cemented together.
Like a fruitcake you mentioned earlier.
Sort of. Geologically speaking, we call those smaller embedded bits clasts. If those clasts were softer, less resistant.
They could erode away faster, leaving the holes.
Exactly. Leaving behind those little hollows or pits, that's one possibility.
And the other idea?
The other involves the Martian wind. It's relentless.
Even with that thin atmosphere.
Even so, over millions, billions of years, wind carrying fine dust and sand acts like a very slow, very persistent sandblaster.
So it could just scour out those pits over eons.
That's the thinking, just gradually wearing away the surface material. Both ideas really emphasize the long timescales and powerful erosional forces on Mars.
Okay, so when you see a dark rock just sitting there on Mars, the first thought, for me anyway, is meteorite. Did that come up?
Oh, absolutely. That's often the go-to initial thought, especially since Curiosity, the other rover.
All right, in Gale Crater.
It has found dark rocks that turned out to be meteorites, usually rich in iron and nickel.
So Skull Hill's dark color fits that profile, initially.
Visually, yes.
Yeah.
It's suggestive. But this is where Perseverance's instruments really shine.
Like the SuperCam with its laser.
Exactly. SuperCam can analyze the chemical composition from a distance. And the recent data from Skull Hill and some similar dark rocks nearby, It doesn't really show the high levels of iron and nickel you'd expect from a typical meteorite like the ones Curiosity found.
Oh,
Hmm.
okay, plot twist. So probably not a visitor from space then.
It seems less likely based on this preliminary chemical data, yeah.
So if not a meteorite, what's the next best guess?
The alternative hypothesis that's really gaining traction is that it could be an igneous rock.
Igneous, like
Yeah.
volcanic.
Precisely. Formed from cooled magma or lava. Mars has a huge volcanic history, remember?
Olympus Mons, the
Mhm.
biggest volcano in the solar system.
Right. And volcanic rocks, igneous rocks, often contain minerals rich in iron and magnesium, things like olivine and pyroxene.
And those make the rock dark.
They certainly can, yes. They're typically dark-colored minerals, very common in volcanic rocks on Earth, and seemingly on Mars, too. That could explain Skull Hill's dark tone.
Okay, that makes sense. If it is igneous, where did it come from? Did it roll down from a nearby volcano?
That's one possibility. Maybe it eroded from a larger volcanic outcrop somewhere nearby in Jezero,
Yeah.
then got
By
transported.
those ancient rivers or whatever moved it.
Correct. Or there's another interesting possibility involving impacts.
Asteroid impacts.
Yeah. A big impact can dig up material from deep underground, stuff that wouldn't normally be at the surface.
Including potentially deeper layers of volcanic rock.
Exactly. And that impact could throw or eject that material quite far across the landscape.
Landing randomly as these float rocks, like Skull Hill.
That's the scenario. So it could be ejected material from an impact crater that dug into older volcanic layers.
Wow. So many possibilities. This really shows why having those analytical instruments on the rover is so vital, doesn't it?
Absolutely critical. It's not just about taking pretty pictures, although Mastcam-Z does that incredibly well.
Right.
It's about getting that chemical fingerprint. That SuperCam data is going to be key to figuring out Skull Hill's actual origin story.
Are they analyzing other similar dark rocks nearby too?
Yes, comparing the composition of Skull Hill to other dark float rocks in that Port Anson area is a big part of the investigation.
Trying to see if they're related, like from the same source.
Exactly. Do they share a common origin? Do they tell a consistent story about the geology of this part of Jezero? That's what they're hoping to determine.
You know, it's easy to get focused on the skull shape, but the fact it's a float rock seems really important scientifically.
It really is. Studying these out-of-place rocks is incredibly valuable. They're like little messengers
Dissenters, right?
from potentially different locations, different geological time periods within Jezero, or maybe even from outside the crater entirely. They give us snapshots of Mars' wider geological history.
And tying this back to the big picture, how does studying rocks like Skull Hill help with the search for ancient life?
Well, understanding the geological history, the types of rocks, the role of water, volcanic activity is fundamental to understanding the environment.
Whether it was habitable, basically.
Precisely. Could Mars have supported microbial life billions of years ago? The rocks hold the clues to those past conditions. Was it warm? Was it wet? What minerals were present?
Every rock a clue. And Skull Hill isn't the only weird thing we've seen on Mars, is it? I remember seeing lists.
Oh, not by a long shot. Mars is full of things that make you do a double take. That article you mentioned, the 32 things, it's quite a collection.
Yeah, like rocks that look like a book. Or a teddy bear's face, seriously.
Seriously. And things described as mineral flowers, which are these delicate-looking formations. Again, mostly pareidolia driving the description.
Seeing familiar things in random shapes.
Right. But sometimes the shapes hint at interesting geological processes.
Mm-hmm.
There was that thing that looked like a doorway, too,
Oh, yeah, I remember that one. And fossilized animal tracks.
which, under scrutiny, usually turn out to be patterns from erosion or mineral formations. But they spark curiosity. They make scientists look closer.
And some things are genuinely significant finds, even if they look odd, like the blueberries.
Absolutely. Those hematite spherules found by Opportunity were huge evidence for past water. Game-changing, really.
And those spiders near the South Pole, they look creepy.
They do. But they turn out to be a really cool seasonal process involving carbon dioxide ice sublimating, turning directly from solid to gas in the spring.
Wow, okay. What about the Inca City? That sounds intriguing.
That's a feature near the South Pole, too, with this almost geometric, grid-like pattern of ridges. Its exact geological origin is still debated, I
It
believe.
just keeps surprising us. What else is on that list?
Oh, let's see. There was that really bright white rock. Perseverance found. A Toco point. Stood out completely.
Yeah. Different composition.
Presumably, yes.
Yeah.
Still being analyzed. And the rock that looked weirdly like the Star Trek insignia.
No way.
Yeah. Just a random rock shape. But the resemblance was uncanny. It really highlights the sheer variety up there.
And sometimes it's our own stuff that looks weird, right? Like pieces of the rover's landing gear.
Definitely. Bits of parachute or heat shield scattered on the surface can look very alien against the red dust.
Man, it's a gallery of oddities. Tile floor patterns, those weirdly perfect circular dunes.
The circular dunes are fascinating examples of wind patterns, and rocks shaped like a shark fin or a crab claw.
Yeah.
Again, pareidolia meets erosion.
The floating spoon, that one was bizarre.
Looked like it, didn't it? Likely a ventifact, a rock shaped by wind, and of course the classic face on Mars.
The ultimate pareidolia example, maybe just shadows and low resolution in the early pictures.
Exactly. Later, higher resolution images showed it was just a mesa, a natural landform. Then there's the giant's fingerprint, which is a type of crater.
It's just endless. The cracked rocks, formations that look like an angel or a heart.
All down to perspective, lighting, and natural geology. But still, they capture the imagination.
What about that green rock with drill holes?
Ah, yes. That turned out to have laser sap marks from Perseverance's supercam. The drill holes were analysis points.
Okay, that makes more sense. And rock candy.
Sulfur crystals, apparently. Beautiful but natural.
And people speculating about bullet holes leading to caves or that weird underground dog anomaly from gravity data.
Right, those push into more speculative territory, but they show how much we're still trying to understand both on and below the surface. There's meteorite debris found, like Ames Knob, the rover's own discarded parachute and back shell.
The alien egg meteorite, swirling patterns of olivine, even an alien monolith-looking structure.
Most, if not all, have scientific explanations. Geology, meteorites, optical illusions, rover parts. But taken together,
It paints a picture of a really alien, complex, and still quite mysterious world.
absolutely. And that's the key takeaway. While natural processes explain most of these, their sheer number and variety show Mars is incredibly dynamic and geologically diverse. Skull Hill fits right into that pattern of discovery.
Okay, so let's try and circle back and sum this up. Skull Hill.
Right, it's this dark, pitted rock. Importantly, it's a float rock. It was moved there, found by Perseverance in Jezero Crater.
The skull shape grabbed headlines, but the science is about its origin.
Correct. It's probably not a standard meteorite, based on the chemistry we have so far.
The leading ideas are pointing towards igneous rock, volcanic.
That seems to be the stronger hypothesis currently, either eroded from a nearby volcanic formation or maybe thrown there by a big impact that dug up deeper volcanic layers.
But the origin is still officially unknown, pending more analysis.
Precisely. It's an ongoing investigation.
And finding things like Skull Hill and all these other oddities, it's significant because
Because each one is a clue. A piece of the puzzle about Mars's geological past. About water. About volcanoes. About the environment over billions of years.
and ultimately about whether Mars could have ever supported life.
That's the driving question behind so much of this exploration. These geological clues build that picture of past habitability.
Okay, so here's something to maybe chew on. We keep finding these unexpected things on Mars, things that look weird, things that don't quite fit our initial ideas. What does that sheer volume of unexpectedness tell us? Does it suggest maybe our models of how planets work, especially alien ones, are still incomplete?
That's a really profound question, actually. I think it absolutely does suggest that. Mars constantly challenges our assumptions.
So we should almost expect the unexpected out there.
I think that's a healthy scientific attitude, yes. These discoveries highlight the complexity, the diversity of planetary processes. What seems weird to us might just be normal for Mars or for other planets.
It really underscores how much more there is to learn, not just about Mars, but, everywhere else in the universe, too. What other surprises are waiting?
Exactly. Our understanding is always evolving, always being refined by new data. Mars is a fantastic laboratory for that, reminding us that the universe is likely far more varied and surprising than we can easily imagine.
A constant source of wonder and scientific mystery. Well said. Thanks for taking this deep dive into Skull Hill and the weird wonders of Mars with us.
My pleasure. Always fascinating to talk about the red planet.
Until next time, keep looking up and keep that curiosity fired up.